I'm clear.
Hey guys, welcome back to Master Poncho's videos. Okay, I'm here with a back. Notes, but blah blah blah. And here we go.
Alrighty then. Okay. Yes. All right. Okay. So now for this one right here.
What the? It's not.
It would have been way louder, but like that.
Thank you. Anyway, all right, you guys. Okay, so now we're going to try and match a graph to its function. Okay, we're going to match a graph to a function here. So I'm going to start by, since I have this graph already, I'm going to start by drawing in what the regular function was and not the inverse. Because right now we're dealing with the reciprocal, I mean. Okay, right now this is a reciprocal function of either sine or cosine, right?
Yes.
So it's either secant or cosecant. So I'm going to start this, and I'm going to connect the dots. So if it's up here, that means my graph had to start here. Up. There we go. Now, this looks like what type of function? Is it starting at 0 or the amplitude?
0. So this is a...
It would be like a sine, right?
Yeah.
So the red line is a sine function, and when I figure it out, then I'm gonna check to see, and it's gonna be the reciprocal of that. So it's gonna be a cosecant function, right?
Mm-hmm.
Yeah.
Okay, so now I have that. So it's sine. What is my amplitude?
1.
Okay, so my amp is 1, right?
Mm-hmm.
I know it's a sine, so it's some type of sine. Now, is there phase shift?
No. Wait, how do you know?
Okay, so now for this one right here, since it's starting here,
Yeah.
there's not going to be a phase shift. If it's starting at 0, there's not going to be a phase shift. If it's starting somewhere else, then I should have a phase shift. Because my graph, this is over one period, if I'm starting at 0, then I don't have a phase shift.
Right.
You'll see it on the next one. I'll show you how.
Okay.
So phase shift is none. What about vertical shift?
No.
Okay, no vertical shift. So V.
That's nice.
So vertical shift is none also. All right. Now, what about period?
It's 4 pi.
Okay, it's going to 4 pi, right?
Mm-hmm.
It starts at 0 and goes to 4 pi. So how far is it from here to here?
4.
So to do the period, I need to figure out how far. So it's going to be 4 pi minus 0, which is just 4 pi, right?
Why did you minus it?
Okay, because that's where it started at. It's going to make more sense when I do one that's not starting at 0. Okay? So when you're going to have to count it backwards to see how far it is. Remember, period is how long the wave is. Okay? How far is it from start to finish? And that's what we have here. So it's going to be 4 pi. Now, what we normally do for sine and cosine, isn't it going to be, it's 2 pi divided by b, but this time I know what my answer is, right? I don't know what the b is. Are you paying attention right now?
Not yet.
So I have this formula set up, but this time it's supposed to equal how much?
4 pi.
It's going to equal 4 pi, and I'm trying to solve for the b value here.
So you basically just do an algebra.
Yes, I do. Thank you.
Break equations. You make
Huh?
equations.
Yeah, I have algebra now, right? Because we're solving for b. Remember, b is in front of my value right here. So it's going to be sine of
Are you gonna put that
vx right here, right?
Are you gonna put that 4 pi over 1 pi?
I'm not going to, because this is how long the period is.
Is B 1 over 2?
How'd you get?
Yeah, I'll get to that here in a second. Yes.
How'd you get 4 pi?
Because
How did I get 4 pi?
what the
No, I know.
Oh, okay.
Because I started at 0, I ended at 4 pi. So it's the end minus the beginning. So it's going to make more sense when we do one that's not starting at 0.
Okay.
Okay? So this is what I normally use to figure out my period, right? So, but we don't know what the b value is because I want to find what that is. So now I'm going to multiply both sides by b, right? Multiply both sides by b.
Oh, yes. Easy.
Okay? So those cancel. So it's 2 pi equals 4 pi b.
Then you divide by 2 pi.
Divide by 4 pi.
Oh.
B
It
equals.
would be pi over.
Because I have to cancel out this. I want the b by itself, right?
Oh, the B, yeah.
So it's going to be 1/2, right? b equals 1/2. So since I don't have a phase shift, I'm not going to have anything else inside these parentheses up here. So the red line is, okay, this is what we have for the red line. But I'm looking for the blue line, right? I'm looking for the blue line. So I did all this just according to this. But I know that the blue line is a reciprocal of the red. So I'm going to go ahead and,
So it's gonna be the same equation just with cosine.
yeah, so this one's going to be, my amplitude is 1, right?
Yep.
So it's going to be the CSC of
1/2 b
1/2
or x.
x.
Yeah. And that's it?
Is there any phase shift?
Nope.
Is there any amplitude other than 1? Is there any vertical shift? No, so we're just left with that.
No. That's easy.
So you just have to draw it in and.
Yeah, start figuring out those other things, right? Now the next one's going to be a little bit more confusing. I'm sorry.
Rip.
There you go. All right, did you get it? Okay, all right. Okay, so determine the graph of this equation. So let's go ahead and do the exact same thing over again.
The amplitude.
So this one, if you notice, what number is this wrapping around? It's not wrapping around the x-axis anymore, is it?
1.
It's wrapping around 1, isn't it?
How do you
Yeah.
know?
Because if you notice where this is, right? So this is going down and up.
It's in between.
What?
Okay, so,
Oh, okay. So
Right.
It's above one.
yeah, so it's up here and it's below here, right?
Yeah.
So if I do this right, I'm going to start here. Okay? I start here and then I'm going to go up to here. So I basically have a dotted line at 1.
And that would be our phase shift or?
Vertical shift. So the whole thing moved up.
Okay.
That is my vertical shift there.
Hopefully that thing still works.
Yeah.
Is there a phase shift too, or?
Okay, maybe.
Yes.
Okay, so now let's take a look. If this is my vertical shift, what's my amplitude? From this line, it goes up 1 and it also goes down 1. So my amplitude is 1. Okay, so the amplitude is 1. It could be a cosine.
It is.
Because it starts at the amp.
Okay, it just depends. So we could actually do this with a phase shift. We could do it as a phase shift because it's starting here. But if I'm starting at 0, right? If I'm starting at 0, won't this still have to keep going up? It's going to have to still go up right there. This would be the cosine, wouldn't it? Going starting here, ending here. But if it's not, is it? It's starting over here,
So it's sine.
going up, down, and here. This is one period.
So it's sine with a phase shift.
Okay, this is one period right here. Okay, so from start to finish, one period. Okay, so now we know what the amplitude is. Okay, if I'm starting at 0, like this one is, okay, because it's 0 and it just moved up with a vertical shift, might as well just put my vertical shift right there, is 1, goes up positive 1, right? So if it's starting right here, this is also going to be a sine, isn't it?
Yeah.
So that's going to be a sine of bx, right? So sine of bx, I don't know what the b is, and I'm still going to have to try and figure out, there's a vertical shift, or a phase shift on this also. So I need to try and figure out that. Now let's go through and let's figure out the period first.
So you would subtract 3 pi over 2 minus negative 2 pi? Or pi 2?
Minus what?
Negative pi 2.
Very good. That's what I said. This is going to apply more on this problem.
So from one.
I know you just woke up right there.
Yeah.
I just noticed that. You just like all of a sudden you're like, crap, what just happened? Okay, so
Wait.
I started with the end. and I subtracted the beginning.
So wherever the two asymptotes are, right?
For this one, it has a whole period. Or it has a whole period here, right? So my end is here, my beginning is here. Huh? Yeah, that's how we're going to find our period. That's one whole wave right here. Did I answer your question,
Yeah.
Zoe? Okay, so I figured out it's from here to here, so in between those two things. So now I'm going to have to try and figure out, what is this one going to be? So is this just going to be 2 pi?
Yeah.
Okay, so this is 2 pi, right?
Yeah.
When I add those together, I get 2 pi. So I'm going to do the same thing I did last time. So it's going to be 2 pi over b is equal to 2 pi, right? And so b ends up just being what? 1. Very good. So my b is going to be 1. That makes sense? Okay, so b has to be 1. So we know that's going to be 1. Now I have a phase shift to deal with, right? Okay, so now, phase shift. Okay.
So could you just take the...
How do I do what?
Get the 2 pi, like, because wouldn't you add them and it would be 4 pi over 2?
Okay, what's 4 divided by 2?
Never mind, yeah.
There we go. Yes.
So could you just take 2 pi and add it to the number at the end? Or subtract it from the number... No, it would be added because you subtract, right? So it's the number 3 pi over 2 or any of them really?
Okay, so now,
Or no?
the easiest thing is, from here, we know that the whole thing is supposed to be 2 pi, but this whole thing is moved over. It's moved to the left, this, right? Remember, it's always opposite the phase shift, right? So if it's opposite the phase shift, I'm doing what? Adding. So I'm going to add now, right? So I'm going to add. Now, how much is it moving over?
So when we got the 2 pi up top, like under the sign of dx, under the sign of dx.
This?
Yeah, that's the phase shift.
No, this is period.
Okay,
That's period.
then what did you do on the bottom?
Okay, so now remember the formula that we used on the last one. Let me back it up. Right here. This formula right here. Okay, so from here it's 2 pi over b, right?
Yeah.
That's what we use to solve our formula. And we usually plug in b because we have the function. We have the function. This time I don't have the function, but I know what the period is, right? So I get 2 pi over b is equal to, what is my period?
So that's the number that's gonna be. Where would you?
And where does b normally go?
Oh, before the x.
Before the x. But now on my problem right here, my b is 1, isn't it? B is 1, so this is just going to be x, right? And now we have a phase shift. And remember, we always subtract the phase shift. Okay, we subtract the phase shift. So if we're subtracting the phase shift, what's this? It's going to be the opposite, isn't it? So it's going to be pi over 2. So my phase shift is going to be pi over 2.
Because b was 1.
Because what? B is 1, yes. Because B is 1. Okay, so right
how
here,
would that look if b wasn't 1? Do you know what I mean?
if B was not 1,
Yeah.
okay,
Like, just say it was 2. You know.
okay, because my phase shift is always whatever number. So if I have, let's say, sine of bx plus d. Okay, this is actually from some of our previous slides. Okay, this is for this. The phase shift, when I factor this out, I would divide it out. So it's going to be supposed to be sine of b parentheses of x plus d divided by b.
So you would just...
Okay, so if you know what b is,
I feel like I've been doing the other shit wrong all this time.
hey,
Sorry. The other
language.
stuff
I'm
wrong
recording
all
this. Come on now.
time.
Yes, no.
Trying to not get demonetized.
Demonetized.
I know, right?
89 cents.
Okay, Now, this is from the formula that it's on the top of your notes. So it usually comes up here, and it's on. Like this.
Yeah, I know that.
It's right here. It's from that.
Yeah, I
And
know.
so it's you're just going to try and solve for it. But if we already know, you know what B is.
Yeah.
And you know this number is going to be this, right?
But I didn't
And
know
this
about
is
the
my
D
phase
over
shift.
B. That's what I'm talking about. D over B is tripping me out. What is that?
Okay, it's just some number.
I get confused on that too, like when I bring my homework.
Okay, because you always have to factor out this. This number right here is my phase shift.
Not D?
No, it's not D.
Dude, I've been doing this wrong.
Because every single time you have to factor this out. Remember, every time when I do these problems, I would take this number here. You have to factor it out. The B has to come out here.
Okay.
Then it's going to be B divided by D. Or, I'm sorry, D divided by B. We haven't had too many problems like this where you do for this last section. Where you actually had to do this division.
Yeah.
Okay? But it is going to come out like that. So now we know what the phase shift is here, right? So in red, it's going to be 1. So it's going to be y equals 1, right? Plus sine, right? Of x
Plus pi over 2.
Plus pi over
Minus pi over 2.
Plus pi over 2.
plus, because it's the opposite.
So if B hadn't had been 1, to find the
Okay, so if you know
to
what
find
this
the
number
phase-
is.
So yeah.
If you know what this number is here, right? Watch this.
Wait.
So we're going to take this piece right here.
Mhm.
So if you know what this number is, you would say equals pi over 2.
Yeah.
So you're most likely going to already know what your B value is because we found that out earlier on.
Yeah.
I found out what the B value is. So it's going to be D divided by, for this case right here, it was 1, right? 1 equals pi over 2. So if you have different numbers, you're just solving for the variable that you don't know. And D just so happened to be on this one, it's going to be pi over 2. A little bit more sense?
Sure.
So in the notes, it says y equals 1 plus c.
Okay, I haven't got that far yet because this is the red, right? This is the red. I'm all dealing with this red, right?
That's only for.
No, just the red one that I drew.
We have to do something else now?
Okay, but what's the blue one? Isn't the blue one the reciprocal? I did all this just to find this one, right? And then the reciprocal is in blue. So the reciprocal of this is going to be y equals 1 plus CSC of x plus pi over 2.
Where'd you get the pi over 2?
Pi over 2. Isn't this shift over pi over 2? My whole period is 2 pi, right? And so that means that this whole thing moved left this amount.
It says secant, not cosecant.
Yeah,
I
and then
know.
it doesn't say
Ours
plus
is
pi over 2.
Okay, I get it. Okay,
So
there's
they
a reason
solved
why.
it
No,
as
no,
a
no, no. This is correct. And the other one is correct if you use secant. But the problem with secant, where does secant start?
0.
Secant. So if you're looking at the notes, it would have to start here and it would have to end here.
And that's what you said at the beginning.
I said that at the beginning, but the problem is we don't have that. We only have this from here to here. So
the
one,
notes
this
are wrong.
whole wave, yes.
Okay.
So you could actually do this. So even if you do say it's a secant, if you were to graph this and you would graph the secant function without the phase shift, you'll get the same answer. Do you want me to show you?
No, because then we're gonna get confusion.
Visual
Yeah, we're gonna
demonstration.
be way more.
No, seriously. If you graph this,
I don't even know what that's based on.
if you graph this, or if you grab the secant without the pi over 2, it's 1 plus secant x, and this one right here, they're both going to be right on top of each other. it's the same line. But from the notes that I gave you, they went from here to here where it's not true. Okay, if you're only looking at this wave right here, you have to have a phase shift because it starts here, it ends here. Make sense?
Yeah.
Okay, so it is possible to have more than one answer on this, especially if you're doing a phase shift. We just move the wave over a little bit.
I don't like graphs.
I know you don't. Sorry.
This is.
It's confusing. I got lost.
It is. It is. I know. I'm watching you like, all of a sudden you like wake up from a short nap and then all of a sudden you're like, "Crap, what's
Everything we do
happening?"
is fairly easy. It's just a long process. It's a lot to
Exactly.
remember, and it makes me want to cry and die and yeah.
Okay. All right. So let's see. Do we need the last one? No.
One of the realest figures.
Okay. Questions, concerns, complaints.
Lots of complaints.
Everyone's complaining.